visit the moon? Have Americans given up on this dream? In Nevada, pioneers turned a barren desert into one of the top tourist destinations in the world. Why can't we do the same for the moon?
The winners of the Google Lunar X Prize will get us to the moon, but the winners of the MoonBots challenge will keep us there and keep us wanting to go back.
But what do we need to do to achieve this goal? If we're going to build structures and colonies on the moon, we must design our structures so they can withstand the harsh environment of the lunar surface, including extreme temperatures, a lack of atmosphere, and dangerous meteorites.
Also, did you know that on the moon there aren't earthquakes but moonquakes? We will have to develop our lunar buildings so they don't suffer any damage and leaks.
During the Apollo program, we placed 5 passive seismometers on the moon and learned that there are 4 types of moonquakes. The most damaging would be shallow moonquakes, which can last several hours and measure up to 5.5 on the Richter scale.
What we saw was way beyond our expectations. What we observed was not just impacts of meteors, but many natural seismic events from deep inside the moon.
Unfortunately, all communications to the Apollo seismometers were turned off on September 30th, 1977. In order to build on the moon, we need more information about lunar seismology.
What surprised us more was how those seismic signals looked. They did not look anything like earthquake signals we are accustomed to see.
According to Apollo research scientist Dr. Yoshio Nakamura, we need a larger network of instruments, possibly including ones on the far side of the moon, in order to better understand shallow moonquakes. This would enable us to determine the depths and locations of these moonquakes more precisely in order to keep future lunar communities safe.
But it's more than just flipping a switch to reactivate these seismometers again. According to Apollo Operations Manager Mr. Jim Bates, the radioisotope thermoelectric generators, or RTGs, that were left on the moon are no longer delivering enough power to repower these seismometers. So we need to deliver a new power source using solar or nuclear technologies.
So, if we could bring a new power source and more seismometers, then it would be possible to learn more using these heritage scientific instruments. These Apollo instruments could still yield valuable information. In fact, these seismometers are connected to a whole series of scientific instruments that were deployed by astronauts in a package called the ALSEP, the Apollo Lunar Surface Experiments package. For example, the ALSEP included a solar wind spectrometer to understand the effects of solar wind on the lunar environment, and LACE, the Lunar Atmospheric Composition Experiment, which detected changes in the atmosphere.
Repowering these seismometers would also repower the other components of the ALSEP in working condition. Another part of the ALSEP includes the retroreflectors, which measure the distance and movement of the moon. They don't require power, but they're becoming less effective and need to be cleaned because of the moon dust that is accumulating on the surface of these mirrors.
If we can utilize these available resources, we can jumpstart our dream of making the moon a new habitable frontier. Not only a vacation destination, but also a launching pad towards further innovation and exploration.
For more information, please visit theincredibots.weebly.com.
We'll see you on the moon!